Hi everyone, my name is Jeff Gratis. I run the North American office for Tantec. We do sales and service out of our Chicago office. Today's webinar will be based on our leak detection technology. Many years ago, Tantec developed a generator that's able to detect arcs when a high voltage probe finds a path to ground. So we were able to take our Corona technology that's able to detect arcs and turn it into a leak detection process. So it's a nice tool that allows for non-destructive testing of plastic injection molded parts to allow us to determine if a hole is present in the part without damaging the part if the part is good. Obviously, if a part is bad, we're able to pass high voltage through that hole, creating a signal to let you know that there's been a detection found or a failure mode. This process only works on non-conductive materials. Injection molded parts are the most common. We're looking for a part that has an opening on the bottom and a closed end on the other side, or maybe a flat wall or sheet or something along those lines that will isolate ground from high voltage, allowing us to do the detection process. So what we're doing here is we're using a DC voltage to measure the voltage or the detection between the plastic and the high voltage. What's great about using the DC voltage is we don't create any type of byproduct or corona or electrical discharge until a leak is present. So if you have a good part and you have the probe over the top of that, nothing is occurring in terms of an output discharge from the electrode that causes you to have to ventilate anything along those lines. When a detection is, or a hole is found and detection is present, there will be an arc that passes through to the metal, and then we provide that signal available to you through the generator. One of the other things that Tantec has done over the years is come up with a way to run an opposed polarity detection process. The opposed polarity detection process provides two values or additions beyond our leak detection. The first being it reduces some of the static present during the detection process, and the second allows us to increase the voltage to a higher voltage level, maybe on a part that might be a little bit thicker, or maybe we're trying to find an even smaller hole. We can go to a higher voltage. If you kind of consider leak detection in the world of finding holes, the higher the voltage, the smaller the hole that can be found, allowing us to pass through that dielectric layer or that opening and getting that high voltage finding its way to ground. So as I mentioned a little bit about the DC voltage and a little bit of generating of static electricity, it is minimal, so it's not overly concerning, but we try to eliminate as much as possible by using the DC voltage. So in order to do this, it's really critical to have an open end where we have a high voltage on one side and the grounded on the other side. So when we talk about parts that are capable of being leak detected, you really have to be able to get that backside ground, and that high other side has to have the high voltage present. During that process, that allows us to create that electrical field that will either go through and find the hole, or it will just simply run its course through its process and then pass the part. Most cases, the detection process time is somewhere between half a second to 1 second. Typically going any longer than that is not necessary. You don't need to go longer to find a smaller hole. It's just a matter of fine-tuning your adjustments in terms of voltage at that point. Tantec systems are going to be designed and developed to fit your application. So there's a lot of different things that can be done here. We can provide both the holder for the part and the high voltage probe. Others, we just simply provide the high voltage probe because the part is already sitting on an existing mandrel or fixture that is usable by Tantec. The most important thing, obviously, is having a good ground and a good solid high voltage on the other side. Other things that are included with the system as potential options, we can do individual detections. So if you've got 8 or 10 parts together in a line and you want to test all of them at once and know which one specifically has failed, we can provide a system that allows us to track them individually. So instead of throwing out 10 parts, you might only throw out 1 part. The other great part about that is you can then see trends in your injection molding process. If you have one cavity that tends to be having more and more problems, that might indicate a problem with your mold or something along those lines, allowing you to make adjustments and eliminate downtime as much as possible. Everyone always asks, what's the smallest hole you can detect? How far down can you detect on the part itself? Typically down in the micron range, 1, 2, 3 micron is usually the range that most people are looking for us to detect. One thing we like to say is if you've got a specific hole that you have a problem with, send the sample to us. Let us go ahead and set up our fixture and see if we can detect the hole for you. A lot of times when we do our samples, our customers send us a grouping of parts knowing which are good and which are bad, send them together with us, we sort them and send them back to confirm that we're able to detect the holes that you're looking for. So it's a great way to help prove out the concept, prove the value of this system and what it can do for you. As I mentioned before, the ability to individually detect them is key for a lot of customers doing high volume that don't want to throw out 10 parts at a time, more interested in knowing which one specifically has failed at that point. So one of the case studies we have here is on injection molding company that I've worked with for many, many years. They do a lot of leak detection of their injection molded, some of their two-part processes as well. And a lot of it just boils down to taking the parts out of the fixture, dropping them onto the grounded mandrel and putting that underneath the high voltage probes, which then run for about a 1-second cycle time, looking to find any breaks of integrity in the part itself. It's a great tool, great device. It's able to run 24 hours a day, 7 days a week. Minimal operator interface. Once the system is up and running, it's going to run with your automation and your injection molding process. So there's very, very little interfacing your operators have to do or work with the system. This customer, like I said, has bought many, many different systems from us over the years and has been extremely happy with the process and the control it's provided to them, and has also helped them build and develop their business with their end user to give them that security that they know that when they do put this cap on a specific part, that whatever's inside that bottle or cap or bottle or vial that they're putting this cap on, the contents will remain in place and there's no risk of leakage. And that's really important, especially when you're dealing with, let's say, pharmaceuticals that are extremely expensive to manufacture. You want to make sure that the product integrity is there by way of making sure the cap doesn't have any leaking going on. This is another case study where we worked with another company providing a multiple up system. This is taking tubes out and testing somewhere between 48 to 64 at a time. We're basically taking them right off the injection molding machine and bringing them over to a fixture. Again, taking the open end, inserting something on that end, and then keeping something on the opposite end to then create the high voltage potential between the two. And when that hole is found, that's when the arc will become present and giving us a signal to the system to tell us which specific cavity has gone bad, to know to then reject that part and then send the other parts along as good parts. So again, a lot of great information comes out of this system and provides a great deal of value to ensure the product integrity that you're shipping out to your customers is. One thing, as I mentioned earlier, if you're interested in something like this for leak detection, we'll happily go ahead and take some samples in from you, do some testing, some verification, provide back to you what we found good, what we found bad, and then let you evaluate, did we find the holes that you're looking for, to give you the confidence that a Tantec system will provide the level of quality you need for your manufacturing process. So we've moved into the applications lab. This will allow us to show you an actual demonstration of the leak detection process. So on this setup here, we've got our generator up top, our transformer. Then we come down through here to the high voltage cable where we rectify the AC into a DC voltage, allowing us to create that leak detection process. Part of the reason we use DC voltage is we don't want to create a corona during our detection process. So this allows us to give a pass-fail very clearly. So some of the setup that we have here is we have our part, which is an injection molded part. We have another part over here we'll actually use for the demonstration. And what we're looking to do is detect a hole in the bottom of this part. The part will then sit in our fixture, which is our counter electrode or our detection side. This is grounded out. So this way, when we put high voltage on the opposite side, the path to ground is what we're looking for. So if a hole is present, the high voltage will pass its way to ground, giving our generator the opportunity to send a signal to the PLC, letting you know that there's been a failure mode. This side here is the high voltage side. This is what's going to set inside this part, in particular with the cavity here. This is going to be connected to the high voltage. Voltages are going to vary depending on the application, but most are somewhere between the 10 to 17,000 volt range. So once the part is placed into the fixture itself, then we bring the high voltage electrode over the top of that, connecting it to the transformer, and then we run our test. Most tests are about 1, maybe 2 seconds long. If a path to ground is found, we'll then send an arc signal out to the PLC to let you know that this part should be rejected at that point. If no detection is found, there is no alarm signal sent out, so this part can then be passed along. So now we're going to go move over and do an actual high voltage leak detection test so you can see what happens when a part passes and what happens when a part fails. So now we're going to run the actual test here. The part that we have currently in place with the electrode inserted in it is considered a good part. So when we run this test here, there shouldn't be any visible signals of anything coming off the system because it's a DC voltage. DC will only present itself when an arc is present. So we're going to go ahead and run this test. We've got our grounded base here, our high voltage probe, and our part sitting inside the fixture. Right now we're going to go ahead and start the test. As you can see, we're currently putting a high voltage through here. You can't see anything happening simply because the generator is not finding a path to ground. We're going to go ahead and show you a screenshot of the HMI so that you can see that we are running the test. We do have voltage present and wattage present, but no failure. So this would be considered a good part or a pass part. Now this HMI setup is going to show you what happens when a part is considered a good part or a pass part, meaning that we don't get this arc alarm. I'm going to activate the test right now. As you can see, we're pulling 13,000 volts, 48 of the 70 watts, and we're getting no alarm. So this would be considered a pass or a good part. So when no alarm condition is present after your cycle time of the test has run, then you can go ahead and consider this a pass part and send it on to its next operation. So we've gone ahead and switched out the parts here. So this part is a known bad part using the same counter electrode, same high voltage setup. In this instance, because we do have a hole present, a visible arc will be seen. That will allow us to send a signal back to the HMI, which gives us a fail mode that can be sent off to your PLC to reject this part instead of passing the part. So we're going to activate the test right now. As you can see, the visible arc is present with this hole being inside this injection molded part, which would then send that signal so you can go ahead and fail the part. Now we'll go ahead and run the test so you can see on the HMI the feedback that you actually get so that you can make the appropriate decision what to do with the part. So here's the HMI screen. You can see our voltage, which is 13,000 volts. Our wattage is at 70 watts. So we wanted to show you what the HMI is going to do when a bad part is found. And you'll see once we start the test, the voltage and the wattage will populate in the actual, but there will be an alarm condition that pops up in the right-hand corner. This is what's going to be your feedback to your PLC to tell you that you have a bad part. So we're going to activate the test right now. So you can see instantly we detected an alarm. We press alarm here, and it tells us we have an arc alarm. That indicates that a path to ground has been found. This would then be generated out of the HMI, then goes off to the PLC of the generator, so you can take that as a pass-fail signal as well. So we're going to go ahead and put the system into stop condition right now. And now we're going to go ahead and show you an animation showing an automated leak detection process with the Tantec system.